The next rule is the sum difference rule. We'll call this rule number 3. Suppose you want to differentiate something like this. Suppose y is equal to f of x plus g of x. So y is the sum of two functions of x. So f of x is one function, g of x is another function of x. What is dy dx in this case? Someone besides Jana. She seems to know her rules of differentiation well. Okay, Ben? Right. Just f prime of x plus g prime of x. In other words, the derivative of a sum of functions is the sum of the derivatives. Sort of what you'd expect intuitively. So what that means is if you have an expression like this, uh, 2x, I think on our quiz on Friday, we had a function like this, didn't we? So using the rules of differentiation, what is dy dx? Okay, Ben? Okay, the derivative of this part is just 2. Notice the exponent's 1. If you bring that 1 down and multiply it times the 2, you get a 2 times x to the 0. X to the 0 power is just 1. So it's just 2. Whenever you have something like that, the derivative is just the coefficient on the variable. Okay, so dy dx is 2, which is the derivative of this part. Call that f of x. Then what is the derivative of g of x? I told you? Yeah, just minus 2x. So really, when you do that differentiation, you're using the sum difference rule. Okay, all right. Where f of x is 2x and g of x is minus x squared. Okay. In the book, this rule is written in a slightly different way. Instead of just writing a plus here, the book writes a plus minus. So in other words, suppose you have f of x minus g of x. Then the derivative is f prime of x minus g prime of x. So then the rule would be generalized by just putting a plus or a minus there. Okay. All right, sum difference rule.